Assalamu alaikum my dear students, hope you are well by the grace of Almighty Allah. Welcome to NIVS Home School. This is Mohammad Emdadul, Assistant Teacher of Mathematics, National Ideal English Version School, Day Shift. Dear students, today I am going to conduct a math class. I am going to conduct a higher math class of class 9. Okay dear students, our today's topic is exercise 1.2 basic discussion part 2. In this part, I will discuss today one function, onto function and inverse function, and I will show you the definition with example, and when I will complete the class then I will selected a question for your homework from exercise 1.2. Okay dear students, let us see at first what is one function. A function f is called one function if images of the elements in its domain always are distinct under that function. So, if x1 and x2 belongs to domain of the function f and x1 is not equal to x2, it means that x1 and x2 are distinct, then their images, it means fx1 and fx2, these two are images of x1 and x2 will be also not equal, it means they will be also distinct. What does it mean? Okay dear students, now try to understand here. What is one function? Suppose I am writing a function here, I am showing a function here. The function is, here is a set A, here is a set B, here is 1, 2, 3. If I write here 3, 5, 7. Now 3 is the image of 1, 5 is the image of 2, 7 is the image of 3. Now here is a function, we can define the function by f. So we can define function, f is a function from a to b, f is a function from a to b. Here the elements of a are, here the elements of a are 1, 2, 3. So these are the domain of f, these are the domain of f. Now elements of b are here 3, 5, 7. Now see here image of 1, it means f of 1 is 3, f of 1 is 3, f of 2 is 5, f of 3 is 7. This is given as image of 1 is 3, so we can write image of 1 is 3, image of 1 means f of 1, image of 2 is 5 and image of 3 is 7. So 3, 5, 7, these are the images of 1, 2 and 3 respectively. Here if you notice, for every distinct element of domain, here the images are also distinct. But if you look another example here, now see, suppose here -2, or we can write here -1, 0, 1. Another set B, here is 1, 0, 1. 1, 0, or we can write here 0, 1. So now see here, this is set A, this is set B. Now if we define the function f in this way, f is a function from A to B and fx equal to x square, then when we will take f of -1, then it will be -1 whole square means 1. So images of -1 is 1, images of -1 is 1. Again if we consider here f of 0, so this will be 0 square means 0. So images of 0 is 0. Now consider the element 1 here. So this will be 1 square, this will be x square means 1 square. So here will be 1 square means 1. So image of 1 is also 1. So now if you notice this function, we are getting image of minus 1 is 1, image of 1 is also 1. In this case, we are not getting the distinct image for every distinct element of domain, but in this case images of distinct elements are distinct. So, this function is 1 1 and this is not 1 1 function, this is not 1 1 function. I think the concept of the function that is 1 1 or not is clear. It means that again I am telling, if the elements of domain are distinct, then the images also will be distinct. Then the function is known as 1 1. Okay, dear students, if we get the same image for the different elements of domain, if we get the same image for the different element of domain, then the function will never be 1 1. Okay, dear students. So, I think the concept of 1 1 function is clear. Now, I will show you onto function. Onto function now. A function f is a function from a to b will be called onto if for every b belongs to b there exists a belongs to a such that f of a is equal to b. So, b equal to range of a. What does it mean? It means that for every b belongs to b, if we get a in a belongs to a, it means that for every elements of b, suppose a is a set and b is another set. Now, if we define a function f from a to b, f is a function from a to b, here the elements of a are 1, 2, 3 and here the elements are 3, 5, 7. Then if we consider this, elements of 1 is 3, 2 is 5, 3 is 7. Now, we can define the function f is a function from a to b. It means that consider fx equal to 2x plus 1, where x belongs to a and fx belongs to b or y belongs to b. It means that first element, or we can consider a belongs to a, belongs to a or b belongs to b. If we define the function in this way, so we will get here, if we put 1, f of 1 will be 2 into 1 plus 1, it means 3. F of 2 will be 2 into 2 plus 2, 2 into 2 plus 1, that is 5, and f of 3 is 2 into 3 plus 1, it means 7. So, 3, 5, 7. These are the images of 1, 2 and 3. Here 3, 5, 7 are the images of 1, 2, 3. It means that every elements of b are the images of the elements of the domain, and all the elements are the images. All the elements are the images. There is no element which is not an element. It means that its range is b. Range and codomain are same. It means range of f equal to b. Range of the function f is b. It means all the elements of b are the images of the elements of a. So, this condition holds by b. For every b belongs to b, there exists a belongs to a such that f of a is equal to b. It means that every elements of b is an image of a. So, we can say all the elements of b will be, all the elements of b are the images of the elements of a. It means that the range and codomain are equal. If the range and codomain are equal or same, then the function is said to be onto. So, the function is said to be onto if the range and codomain are same. So, I hope you have understood the concept of onto function. Now I want to show the inverse function. Inverse function. Suppose f is a function from a to b is 1 1 and onto function. It means the function f is 1 1 and onto. Condition f is 1 1 and f is onto. It means f holds the condition f is 1 1 and onto both. Now if a function g, if we define from b to a, we have defined the function f from a to b and another function g from b to a is described where for every b belongs to b, we will get for every b belongs to b, g of b equal to a. This function can be described in this way. If and only if for every a belongs to for every f of a equal to b, that function g is defined as the inverse function of f. This is indicated by f inverse. So g is equal to f inverse. G is equal to f inverse. What does it mean? It means that if the function f is 1 1 and onto and f is a function from a to b, there exists another function g that is from b to a, In this case, the elements of the set b and here a, it means set of a, elements of a are the images of b, Conversely, for the function f of a equal to b, and in that case this function g is said to be the inverse of f, and we can then write g is the inverse function of f, and we can denote this by g equal to f inverse. It means we can write here in this way f to the power minus 1. It means that f inverse. So then g is called the inverse function of f. Dear students, we can see an example of a function is said to be inverse or not. Now consider f(x) is a function. The function is f(x) equal to x plus 5. So in this case we can write here in what will be the inverse function of f. Suppose g is the inverse function of f, so we need to determine g, or we can write here, consider y equal to fx, then we can get here fx means x plus 5, so we can write here fx means x plus 5. We can determine the value of x here, that is y minus 5. F means x means f inverse of y, that is y minus 5. Now replace this y by x, you will get here f inverse of x minus 5. So inverse function of f will be f inverse, that is x minus 5, x plus 5. Inverse function of fx equal to x plus 5 is f inverse x equal to x minus 5. Okay, dear students, so I hope you have understood. Here you need to check that the function f is 1 1 or onto or not. You can check by taking any element. This function will be 1 1 and onto both, and then you can determine the inverse function. But you need to remember that if a function is not 1 1 or if it is not onto, then we can determine the inverse function. It means that the function have no inverse function. The function has no inverse function if it is not 1 1 or onto. It means that the function must have inverse function when it is 1 1 and onto. It means if any function condition if any function satisfy these two condition, if the function is 1 1 onto 1 1 and onto, then we will get the inverse function of that function. Okay, dear students. Now see, one question is given for your homework in today's class. This is your homework 10. You have to do question 9 from exercise 1.2 as your homework. Dear students, do your homework properly. Submit your homework on next Saturday from 9 a.m. to 3 p.m. in the school campus. Keep practicing at home. Abide by your parents. Stay home. Stay safe. See you again. Till then, Assalamu alaikum.